and we can go to a new topic, which is path analysis. So let's briefly discuss about basics of this model. So we will make a brief introduction into path analysis logic by pictures and equations, and then we will of course move into real life computations. So first of all, let's start with this simple picture, which is example of path analysis. And we can very easily say that path analysis is nothing more than set of regressions in which usually dependent variable from one regression is independent variable in another regression. Let's briefly describe this picture by this logic. So the first regression...
sorry, I think you were frozen for 30 seconds or so.
Once again?
Yes, well, you were frozen, so if you can start.
So now, can you hear me?
Yes, now, yes.
Okay. So sorry for that. So path analysis is a set of regressions in which dependent variable from one regression is then independent variable in another regression. So let's go to this picture and let's describe this phenomenon. So here we have I1 as dependent variable for regression in which we have x1 and x2 as predictors. So here I would say these are two independent and this is dependent. But here I have the second regression in which I1 plays role of independent variable and also x1 is playing the role of independent variable. So this is the first regression and this is the second regression. So these two regressions, advanced and more of course, are called as path analysis. One more comment should be added to this picture, that all variables for classical path analysis are observed. So here we are using squares or rectangles as symbols that all these variables are present in my data. And some more comments and some key terms will be described on the next slide. So let's go for this. So here we have the slide number 4. And first of all, we would need maybe slightly different wording than dependent and independent variable. Once again, Y1, excuse me, plays role here of dependent variable for this first regression, but independent variable for this second regression. So can we call Y1 as dependent or independent? Both or none can be true. So that's why usually in structural equation models, we are not using terms such as dependent and independent, but we are using slightly different terms that are present here, exogenous and endogenous variables. So what does it mean? I guess that as you are familiar with a little bit Latin expression, you are able to recognize that exogenous means that these variables are not explained, are not influenced by my model. So in other words, in structural equation modeling, these exogenous variables are those variables that are not influenced by my model. It means that there is no one or single-headed arrow going into this variable. So here x1 and x2 are classical exogenous variables. So there is no single-headed arrow going into these variables. Maybe there can be double-headed arrow here. So it means expectation that these two predictors are somehow correlated, but no single-headed arrow going to x1, x2. That's why they are called exogenous. And endogenous variables, it is quite easy to guess, are just the rest of variables. So it means variables that are explained by my model, and at least one single-headed arrow is going into this variable. So y1 and y2 are two endogenous variables, excuse me. My question is related to these random errors. Are these random errors for y1 and y2 exogenous or endogenous?
Exogenous?
Yeah, of course. So random errors are also exogenous variables. So original predictors, let's call it like this way, and these two random errors are 4 exogenous variables and 2 endogenous are y1, y2. One more, I would say, recap here is that for every, and now we would call it endogenous variables, not a dependent variable, we must add this random error as y1 and y2 is somehow explained by the model. So it means there must be also some space for unexplained variance. And this space is fulfilled by these random errors. So there is a rule in structural equation modeling that for every endogenous variable, you must assign this random error. I would say that quite nice information from JASP is that JASP will do it for us automatically. So we would need only to describe these equations, these regressions, and these random errors will be assigned automatically in JASP. But be careful, not all software packages do it like this way. So sometimes it is also necessary to add these random errors by hand. So it means by equations or by pictures. So this is a description of exogenous and endogenous variables. And we will replace discussion about dependent and independent by these endogenous, exogenous terms. Next, two terms that are necessary here to define are so-called direct effects and indirect effects. So, for example, as you can see, x1 is influencing directly, there is single-headed arrow y2. So this is direct effect. This is also direct effect. That's also direct effect. And this is the last one, fourth direct effect in my model. So here is the first one, second one, third one, and the fourth one. So these are direct effects. But you can also recognize in this model that x1 is influencing directly y2, but also indirectly, and this indirect effect is mediated. This is official term, and also we are usually describing something what is called mediation analysis in structural equation modeling. So indirect effect of x1 on y2 is mediated by y1. You can also, for example, check that for a model, there is no direct link, no direct effect of x2 on y2. There is expectation, there is no such, but there is indirect effect going to here. And I would like to add one more comment. If you take this direct effect, and if you take, for example, this indirect effect, these two effects together create something that is called total effects. So we are differentiating direct effects and indirect effects. And if you sum up direct effect and indirect effect, you would get so-called total effect. So if you are applying models such as path analysis, you are usually evaluating also indirect effects and total effects. Once again, JASP would help us a lot in this evaluation. But you should at least know how to evaluate indirect effect. So it means what is the impact of x1 on y2 mediated by y1. So this is very easy. If here we have some effect, it means some regression coefficient, and here we have another regression coefficient. Let's simply call this one as A and B. So this indirect effect can be computed as A multiplied by B. So you should remember that indirect effects are computed as multiplication of individual direct effects by which you go from one variable to the final variable. So that's discussion about direct and indirect effects in path analysis or generally in structural equation modeling. So that's all, I hope so, what is necessary for us to recognize in this path analysis case. And now we would move forward to real life computations. And here is the model we would be computing. So we would replicate the study which was published by Jitka Vaculíková and me in 2019 in one of Spanish psychological journals. So you can find the study, I expect, online. And this was a replication of a well-known American study, which was expecting following relationship: social support and proactive coping as predictors of well-being. We have covered this topic previously by our regression staff. And at the end of this model is depression. So, first of all, before we start to compute, I would like to ask you if you can help me to recognize which variables here in this model are exogenous and which variables are endogenous. So how many exogenous and how many endogenous variables we have, and what are these?
I think there is one exogenous variable, SS.
One exogenous?
One exogenous.
And what about E1, E2, E3?
Or two. But E3, E2, and E1, are they variables, or they are just errors?
They are, at least from structural equation modeling, called as latent variables. So they are variables at all. But you are right that if we are discussing about manifest variables, there is only one: social support. Okay. And endogenous?
And endogenous, like three others. PC,
okay, PC,
WB,
depression. Okay, that's nice. Okay, the next question related to this picture: how many regressions are included here in this path analysis example? How many regressions you can see? And what are these regressions equations behind? So maybe that the first regression is proactive coping is regressed on social support. So this is the first one. How many other regression equations are included here? So what is the next regression? Please help me.
SS on WB.
Not only SS, but also proactive coping. So there are two predictors here. So this is the second regression. And the last one?
WB on depression.
Yes, this is the third one. So here we have three regression equations. And it means that if we would define this model via structural equation modeling in JASP, so it would be necessary to add three equations into one model. So that's the next insight. Maybe some more insight before we start to compute results. So maybe that you remember from today's previous lecture that well-being was regressed on social support and proactive coping, and that the impact of these two variables maybe was the same. So maybe there is also possible to take these two coefficients with the same value. So maybe that fixing could be promising way here at the beginning of this model. Both of these relationships were positive, if you remember well. Also, not by regression, but by correlation or covariance, we computed the relationship for social support and proactive coping, and it was also positive. So this is expected to be positive. This is expected to be positive. This is also expected to be positive, maybe that these two could be the same value. And what is the expectation for this last part of the model? Well-being on depression, depression on well-being. Positive or negative?
Negative.
Yeah, we have covered this topic by correlation previously, and we know that this correlation was quite strong, negative relationship. So here we are expecting quite strong negative relationship in this regression. So that's about assumptions. And now let's go into computations. There are two options in JASP. Unfortunately, there is no direct option for clicking. So we would need once again to type equations, but there is at least a little bit help as JASP is including mediation analysis. We have covered discussion about mediation analysis. It means there is some mediator which is transferring the impact of these variables to the final variable, but our model is not classical mediation analysis, as at least at the beginning there is some relationship by regression for first two predictors, but it is nearly the same as mediation, only this link shouldn't be here for mediation. I would call it like this way. So there is an option to use mediation analysis that can help us to learn how we can type Lavan syntax. So if you like to help from JASP, there is an option to go into mediation analysis and to ask for Lavan syntax and to see how it works. And if you would like precisely to replicate this model, there is no other option than to go to direct structural equation general models and to type our commands by Lavan. So these two ways we would go in next minutes and we would evaluate this model. So first of all, before we start, only we would briefly sum up what is necessary to compute. First of all, we would like to evaluate the model as a whole. Then we would like to evaluate individual coefficients, maybe also some indirect and direct passes, maybe total effects could be also important, as here, for example, there is direct effect, here indirect effect, and this one plus this one makes total effect. So there is quite big space for computation of these direct and indirect effects. And then we can maybe slightly modify the model. And we know that maybe good modification should be that we pose equality constraint. So it means that we would say that these two coefficients could be the same. So maybe this would be our last step for this evaluation. So that's how we would proceed our analysis. So I would skip into JASP once again. And first of all, we would learn how we could apply the procedure for mediation analysis to learn about commands in Lavan, especially how we could evaluate direct and indirect effects. And then we would switch once again into this structural equation modeling general stuff. So first of all, I would only check that my data are correct. So it means well-being, depression, social support, proactive coping. So these four variables are prepared for us. And let's go into SEM. And the second option here is mediation analysis. So this is quite nice. Once again, clicking platform. So it means here we have list of variables, and here we have some windows for computations. So if I would like to have similar model, not the same as we have here, I can define depression as the final outcome. So I would take depression and take it as outcome. Then I can take also well-being as mediator. So well-being would be mediator. and two predictors would be social support and proactive coping. Once again, this is not the same model as we have here. For this model, this link would be missing, so it is nearly the same. Of course, this random error would be missing, but once again, we are trying to proceed such model only to see what are command syntax for Lavaan behind the scene. So I would go here into options, and here you can ask for Lavaan syntax. So if you ask for Lavaan syntax directly in output window, this would be, I guess, the last one output here, you can find what is the description of our model. So here is some regression. So depression is based on well-being, social support, and proactive coping. And well-being is also based on social support and proactive coping. So this is classical mediation model. Once again, slightly different from ours. But you can also check here, and this is quite nice, how to define indirect effects. So here it is, the description. So every time you like to have some indirect effects, you must assign some name. Here it is IND X1 and 1 by 1. Assignment for indirect effects is this symbol. So this is the last symbol we would add. So not only tilde, double tilde, or tilde equality, but also these two symbols are assigned for indirect effects, and you multiply coefficients which are creating indirect effects. So we have learned here how to compute indirect effect, and you can also learn here that total effect could be once again assigned as indirect effect, so this style, plus direct effect. So we would do the same step for our model, and we would be using this as help for our real model. So currently I would cancel this mediation model, as we are not computing real mediation model, but we know how we can compute indirect effects and total effects. So we would be able to replicate our current model. So I would cancel this out, and I would ask for general structural equation models. Here it is. And we would start to type our current model. So I would call it only path analysis. Currently, no fixing would be added. Once again, so no fixing. And let's start to enter Lavaan syntax for our model. So the first part for our model, and I would maybe type it here to see our results. So the first part of the model would be proactive coping regressed on social support. So I would type PC, pan tilde, must go slightly down, sorry for that. Proactive coping on social support. Of course, all letters are small one. So this would be the first equation. And for better computation of indirect effects, I would add maybe some letter or maybe letters and numbers to this coefficient. So maybe I would call this coefficient as B1. So I would type PC multiplied by V1 social support. So this would be my first regression. So I would copy this equation here. So this is the first part. So it means that this regression coefficient is called B1. Let's go to the next. Maybe I will slightly move up, sorry, not this frame, but the picture, if it would be possible. Okay, so we would move it to have an option to write more equations. So this is PC B1 multiplied by SS. So what would be the second equation? Can somebody help me?
well-being regressed with SS and PC.
Well-being regressed on SS plus PC. And once again, I would add some description of individual slopes. So maybe that the next one would be called B2 and the next one B3. So once again, I would take this second equation and I would copy it into just Lavan window. Individual rows should be individual equations. So this is the next one. So it means this is the regression of well-being on social support and proactive coping. Okay, and what would be the next one, the last one?
WB.
Not depression would be dependent. Depression. Regressed
to the WB.
Regressed on
WB.
well-being. And once again, I would assign some name to this coefficient and I would go to B4 maybe. Yeah. So depression tilde B4 multiplied by well-being. Okay, so here we have 1, 2, 3, 4 direct effects that are called B1, B2, B3, B4. And once again, we know that we can, for example, evaluate some indirect effect. There are more than one indirect effects here. So I would, for simplicity, as an example, to take only one of these. So I would take indirect effect from social support to well-being, which is mediated by proactive coping. So I would go this way. So this is indirect effect of social support on proactive coping. This is the direct effect. And once again, sum of indirect and direct is called total effect. So if I would like to compute indirect effect, I would call it that it would be, sorry for this typo. So once again, I would type indirect, underlined. It would be from social support to well-being. So A, I, and D, underlined SS, underlined WB. Then assignment symbol in Lavan. And then I need to define what is the computation of this indirect effect. So can somebody help me which coefficients should be multiplied if I am evaluating this indirect effect? So from SS to PC, it is B1. So it is B1 multiplied by what? What is the symbol for regression well-being on proactive coping?
Multiplied with B3.
Yeah, that's it. B3 is this coefficient. So it is multiplied by B3. Okay, so that's one example of indirect effect of social support on well-being. Of course, I could also evaluate, for example, indirect effect of social support on depression. It would go this way as well as this way. So I would need to sum up two effects, but we wouldn't go into such a slightly complicated step. But I would like to add also maybe total effect of social support on well-being. So what would be total effect of social support on well-being? It would be direct effect plus indirect effect. So I would add one more description, one more equation. So it would be total effect. Once again. Total effect, once again, social support, well-being. Once again, assignment in Lavan. And what should be summed up, what should be written here?
Independent SSWB plus.
So this one?
Yes.
Okay. Multiply, sorry, plus what?
Plus B2.
B2, yeah. That's correct, definitely. So once again, B2. So this is only one example of indirect effect and one example of total effect. And if I add these two equations or assignments, let's call it maybe, so it means that I would get into output, so it means into classical parameter estimates table, so it means table like this one, two more rows with these results of indirect and total effects. Once again, there are more than one indirect effect, there are more than one total effects here for this analysis, but this is only example, so I can take it as it is. It is enough for us to understand. So I would make a copy once again of these two rows. So you would get these 5 rows as commands for the evaluation of basic direct effects and also for one indirect and one total effect. If you would like to evaluate more, of course, you can go further, but we are, of course, also limited by time, so we will go into other indirect and total effects here. So here it is. So that's definition of our path analysis. And I would only maybe ask for some more results. So I would ask for statistics, and at least you can ask for additional fit measures. And maybe we can also ask for R-squared. If you would see your results in a few minutes, it would be maybe surprised that there wouldn't be no one R-squared, but there would be more R-squared, as once again, here we have one regression, second regression, and the third regression, and for all of these, we would have individual R-squares. So that's only to understand these R-squared statistics. And maybe, but it would maybe take some time. We can go into advanced and we can check whether our model is correct or not by path diagram. So you can ask also for path diagram here. So if you set up these settings, you can go once again into Lavande syntax window and click Ctrl plus Enter and wait for results. So here currently model is applied, so it is necessary to wait a minute. And once again, what should be done would be the evaluation of the model as a whole, and then, of course, evaluation of individual direct and indirect and total effects as we have defined. So still, it seems that just computed our results or not, maybe not. No, we are still computing, but at least I have at least some results. Maybe that the chart is not present here, but we can go at least to basic results. And first of all, we can start the evaluation of the model as a whole. Maybe before we start, we can discuss about degrees of freedom here for this model. So if I go back to this model, I can say that originally I have 1, 2, 3, 4 variables. So it means that I am using 1, 2, 3, 4 variances, and I am using also covariances for all possible pairs, how many pairs I can create from 4 variables. Do you know how many pairs I can create if I have 4 variables? So this is the same as if 4 teams goes to the tournament and every team should play with each other once. How
6.
many? Sorry?
It's 6. Sorry to interrupt you.
Okay, okay. How we can compute this?
I know the equation. It's always n multiplied by n minus 1 divided by 2.
Yeah, you are definitely correct. Yeah, that's the rule for these combinations. So you would take the number of units multiplied by number of units minus 1 divided by 2. So here it is 6. Thanks for that. So we have 4 variances and 6 covariances. So it means in total 10 individual information pieces at the beginning. And what we are estimating here So we are estimating 1, 2, 3, 4 regression slopes. So these are 4 regression slopes, and we are estimating 1, 2, 3, 4 variances for exogenous variables. So it means in total 8 parameters, 10 pieces of information, 8 estimated parameters. 10 minus 8 gives 2. So degrees of freedom is 2. So that's correct. And here we have chi-square test evaluation and p-value. So chi-square is 3.2 and p-value is 0.194. I would like only to add that for 2 degrees of freedom, for 95% quantile, chi-square is approximately 6, precisely 5.99 if I remember well, from statistical tables. So it is much lower, and p-value is quite big one. So what would be the evaluation of this model? Seems promising or not?
Yes, it seems promising.
Okay, so we are currently discussing about this model, and it seems that this model could be correct for my data. So that's quite nice message from this first evaluation. Of course, if you like to evaluate it by detail, you can, of course, go into these CFIs, TLIs, and other statistics. But as you can check, CFI, TLI, nearly 1. RMSEI, it is lower than 0.4, and SRMR, it is also quite low value. So all these indices are quite pleasant. So it seems that this model is good. Once again, if you are applying such simple model as we are applying here, so it means path analysis, and your data file is not too big, we have approximately 400 units, so we can apply this chi-square test, and it's not necessary to go into these alternative criteria. But if we would apply some slightly complicated model or using bigger data, then there is a time for these alternative criteria. We would be using these alternative criteria for later models devoted to confirmatory factor analysis. So that's only information about our future. And if I go back, so I cannot see my path diagram, so sorry for that, but you should see the picture. I'm not sure if you can see the picture, which is the same as mine. Can you see the picture on your computer or not? Or do you have the same warning message as I have here?
I have the same message, so I can't see it.
So sorry for that. There is some new maybe mess in JESP, but I guess that the next version will improve it. So sorry for that. So now we would go into computational details. So it means in the table of parameter estimates, and we would go also in the table which is called R-squared. Maybe for simplicity, I would go once again into advanced option, and I would cancel the path diagram, not to have an unpleasant message about mistake. And now we would go into computational details. So first of all, here we have individual coefficients. So B1, B2, B3, B4, as we have defined previously. So for example, proactive coping, social support, slight positive impact. So here it is. This is slight positive impact, 0.2. The next one is 0.3 to 9, well-being social support. So this is this direct effect. The second direct effect here from proactive coping to well-being is 0.357. And the last one, quite negative effect expected from well-being to depression, 0.479. These effects cannot be directly compared, as the scale, especially the variances for individual variables, are not the same. So if you would like to compare the impact of these individual coefficients, you would go into standardized coefficients, and you can recognize very easily that the biggest impact, it's not a big surprise, we have discovered this phenomenon previously, is from depression to well-being. Minus 0.617 is the value which is present here. And the rest are approximately 1/2 or 1/3 of these values, 0.3 or 0.24. You can see the coefficients standardized here. As we have here some sample data for Czech students, we would like maybe also to evaluate whether these impacts of social support, proactive coping from proactive coping to well-being, from social support to well-being, and from well-being to depression can be generalized to the whole population. And you can try to evaluate this generalization of results from sample to the population by testing. So here we have tests, test statistics and p-values. And as you can see, all these p-values are quite low one. So it seems promising that all these effects are not present only for my sample, but could be found also for the whole population of Czech university students, as this was sample for Czech university students. So this is another description of my result, and I could also interpret these confidence intervals. So it means that, for example, this estimate for my sample 0.2 could be for the whole population, maybe slightly lower or slightly bigger. So this would be the interpretation of these results. Last one, what we would like to cover would be how good or bad are individual regressions. So it means what is the size of the explained variance for proactive coping, well-being, and depression. So here we would have 1, 2, 3 R-squares. We could compute these R-squares indirectly from these random errors in standardized version, but maybe it is much easier to go down and to find here R-squared. So it means proactive coping is quite weakly described by my model, slightly less than 10%. Well-being, it is 2 times higher, approximately 20. And the best explanation, it's not a big surprise, as we know that this relationship was quite strong, is for depression, 0.381. So these are R-squares for these depression, well-being, and proactive coping. So this is the next part of this evaluation. And the last one part, which we also added to this model, are the last 2 rows for parameter estimates. So it means indirect effect of social support on well-being. And so this was this indirect effect. And then computation of total effect, it means direct effect plus indirect effect. As you can see here, here we have labels that we assign to these effects. So indirect and total from social to well-being. And here are estimates and also their evaluation. And I must say that this statistical evaluation is not very easy for these indirect and total effects. So it's quite nice that JESP implemented these options from Laban package, as some structural equation model packages do not include such computations. So I can see, for example, that indirect effect from social support to well-being is quite small one. If I compare it with previous direct effect, which was B2, so it means this coefficient. So this is maybe 4 times lower or maybe 5 times lower than direct effect, but still statistically significant. It means that maybe this indirect effect is present also for the whole population of Czech university students. So this is this indirect effect and its evaluation by test as well as by confidence interval. And last one row is describing total effect. It is nothing more than sum up of this indirect effect and this direct effect. So 0.329 plus 0.074 gives 0.403. You can check it, but it should be correct. And once again, the effect is evaluated. So here I can conclude that this direct effect is much stronger than this indirect effect, and I can also evaluate sum up, so it means total effect of social support on well-being. So social support doesn't influence well-being not only directly, but also indirectly, but this indirect effect is quite weak one. It would be my conclusion here. So this is discussion about direct effects, indirect effects, and about evaluation of individual pieces of the model. And the last one step today we would go together would be that we can also once again add some fixing into a model. Once again, if I go back to this picture, we know that maybe these two coefficients, so it means these two direct effects of social support and well-being, proactive coping on well-being, are maybe the same. So I can slightly modify my model by fixing of these two parameters to be the same. You know that the option how we can prepare such fixing is that these two parameters could have the same name. That's one option. I can also, I guess, can use another option. So I would make a copy of this path analysis. So here we have the copy. I would only slightly change the title. So it would be path analyzing and fixing of parameters. And if I go back to my picture, I need to recognize what is the description of this parameter from SS to well-being and from proactive coping to well-being. So let's find these parameters, and these parameters are called B2 and B3. You can find it also here. This B2 is this parameter, and B3 is this parameter. So instead of replacing B2 and B3 by the same symbol such as B or B2 for both, I can also assign equality sign here. So the rule is, I hope so, in JASP, that I would add one condition. So I would maybe once again slightly move this picture up. I will move up also these equations, and I would add one more rule, that B2 is equal, and if I remember well, equality sign for package Lavan is double equality, so equal B3. So if you type B2 double times equal B3, so this would add condition that these two coefficients should be the same for computation. So let's try whether it works. So I would go here. I would type B2 equal B3, and once again run the model, Control plus Enter. So we would get one more degrees of freedom. So it means 3 degrees of freedom, and B2, B3 should be the same value. And according to my opinion, it seems it works as we have 3 degrees of freedom. B2 and B3 both have the same value, not only unstandardized, but also standardized. Only unstandardized. Standardized should be different, as the variances are not the same. And here we have 3 degrees of freedom. And my last question today to this common example is that if we would like to evaluate this model, so it means this is the same model as we have here, and we are also expecting that these two regression coefficients are the same, whether we can apply this model or whether this model seems incorrect. So what's your opinion?
It seems correct.
Yeah, as you can see, 3 degrees of freedom, chi-square 3.3, and p-value is 0.337. So it seems that maybe this model could be also correct. And one more comment we would add, I would go once again to the presentation. I can skip slides about the evaluations as we have discussed all these evaluations, or nearly all of these evaluations, but only new one step, sorry for my typo, I will check it, change it. We would briefly discuss about so-called information criteria. So these two AICs and BICs are so-called information criteria, and these information criteria are usually applied in structural equation modeling as well as in another advanced modeling approaches for comparison of models for the same data. So here we have original model with no fixing and current model with fixing. And the logic is that you compare AIC or BIC for current model and maybe previous model, so we can go up. So here we have 966, 995 or 996, and here we have 989 or 990 and 965. And we can compare AIC or BIC, and the logic is very simple. If the value of BIC or AIC is lower, so then the model is better than the second compared model. So for example, if I compare here BIC approximately 990 with previous one model with no fixing at all, which was 996, and recommendation is that if the difference is more than 5, the better model with small BIC, I can conclude here that maybe this fixing, so it means model which expects that relationship for proactive coping and well-being and social support and well-being is the same, is maybe better. So I can use these AICs and BICs for comparison of different model based on the same data. So that's the big advantage of these AICs and BICs. I would like only to add that social scientists usually use especially AICs and BICs and mostly, especially in sociology, we are preferring BIC. And if you would go, for example, into economics, they usually prefer AIC. So that's only recommendation. There is big fight for those who are advocating AIC and BIC. You can see this discussion at this webpage, so we can go further. So I would skip the rest. We would discuss rules for model building next time. And now I would like only to go to the last slide, which is about your own practicing. So once again, I would like to ask you if you can once again go to Blau-Duncan data, and you would take for a minute the model. I will try to find it as a picture for you to have a chance to replicate classical Blau-Duncan model. So sorry for a minute. I will only stop recording for this